Hey guys, it's Jarrod from JT Electrical Group. Going to do a little bit of a different video today. Currently, we're halfway through 2025 and we've done a couple of trade shows earlier this year already. One being the Caravan and Camping Super Show in Sydney, the week-long one. And another one more recently being the Outdoor Living and Caravan Expo in Tamworth. Now, at both of these shows, I was asked to hold a seminar for the patrons of the show and give them a bit of an education on a couple of topics in regards to electrical installations, lithium batteries, AGM batteries. So we had a lot of people at the show that had very good feedback, but we also had a lot of people that didn't make it to the seminar and wanted to have somewhere to have a look and go through what we spoke about at the show. So that's the purpose of this video. We are going to touch on converting from AGM to lithium batteries, are they safe, and how to read their rules, read their specs, and then the AS 3001 electrical installation laws. Now that's probably the most important part of this video. The rules are very long and we're just going to sort of touch on the main points. But if you follow the sort of main points that we talk about, there's a couple of things like the solar section and stuff that we don't touch on, which I can add to this video as well. So we'll get into it. I'm going to go through on the screen in front of me here and it'll be mirrored so you'll still be able to see me and see the screen. I'm the founder of JT Electrical Group and Element 3 Battery Technology. JT Electrical Group has been operating for 5 to 6 years now. I've been in the industry for about 7 to 8 years. I'm a licensed electrician by trade, and by law, my license is able to certify vehicles, certify electrical systems, which is what we find is a lot of our work. The Element 3 side of the business, that's all our retail side of the business, and you can see a couple of bits and pieces over here, which we're going to talk about in a later YouTube video and sort of introduce that part of our brand as well. Now, one thing that I want you to get from going through this seminar is, one, lithium batteries are safe, and two, the installation of the systems is very, very important. Being a licensed electrician, 240 volt AC can kill you and it's invisible. That's what I tell my apprentices. Everyone automatically thinks, oh yeah, 12 volt DC, like I can touch it, nothing happens, it's safe, I can do it myself, essentially. It is the case, yes, you can do it yourself, but if something goes wrong, one, it falls back on you, and two, if you don't do your homework and you don't know how to do the installation properly, you're gonna run into issues. I've never met someone who doesn't have electrical gremlins in their system, and you could lose vehicle or lose a life if you don't do the installation properly. We're going to go through some of the things that we see later on in this seminar, but we'll touch into our 4 topics that we're going to talk about. So swapping from AGM or lead acid to lithium batteries, how safe are lithium batteries, how to read the specs of a lithium battery, and the electrical installation laws in RVs and caravans. So first topic is swapping from AGM to lithium batteries, or AGM or lead acid. Now, I see AGM and a lead acid battery as the same type of battery. They've both got the main characteristic of 50% usable energy. So if you've got a 100 amp hour AGM or 100 amp hour lead acid battery, your actual usable capacity of that battery is only 50 amp hours. So you've got 100 amp hours, 50 amp hours, that's the only amount of energy that you can use in that battery. Compare that to a lithium, you can use the full 100%. Okay, left side and right side of the screen here, we've got a couple of dot points of each battery. The cycle life, at the top here, first dot point, we'll touch on this a little bit in the next slide. 3,000 plus cycles to 80% DOD. Now, DOD stands for depth of discharge, and this is when we have a battery that is 100% fully charged, and we drain that down to the last 20%. That's 80% DOD. So we've used 80% of it. Lithium battery, 90% of the ones on the market in Australia will be rated to at least 3,000 plus cycles. Depends on the cells, but that's rule of thumb. Now, if we're doing a cycle every day, so we're draining it from 100% to 20% every 24 hours, and then it's getting recharged, doing that every 24 hours, that gives you a lifespan of just over 8 years for a lithium battery. Now, we compare that to AGM. A AGM battery will be rated to roughly 500 cycles to 80% depth of discharge. Now, doing a cycle a day, that's only 1.5 years if you're doing a cycle every day. What we touched on just before, the next dot point, 100% usable capacity compared to 50% usable capacity, and then our weight. Weights, everyone knows about weights of lithium. Here we've got two batteries that are on the market, which will be in the next slide, and these are their weights. So your lithium, for the same amount of, or actually double the capacity of usable capacity, you've got less than half the weight. Fourth dot point down on the lithium, higher nominal voltage equals less voltage drop. Now, a lithium battery with some good cells in it will stay at a higher nominal voltage for longer. Batteries that we use, they'll sit well and truly above like 13.4, 13.5, 13.6, around that sort of mark for the first 60-70% of their capacity usage. I even had a battery under the display at the show last week in Tamworth, and it was a 300 ampere lithium. It was sitting at like 13.03 volts at like 26%, I think. And I boiled my kettle to make a coffee at the show, and I think it dropped down to like 12.6, running at minus 200 amps. That's great. That's exactly what you should see. To have a lithium battery that can still be sitting at 20% and still run comfortably at minus 200 amps, running a kettle or something of that nature, that's perfect. That's a good battery. That's exactly what you want. As where AGMs, they'll run at a lower voltage. They'll sit at that 13.2, and then as soon as you take the first bit off the top, they'll start to drop down to that 12.8, 12.6 mark. Less voltage means more resistance. So voltage drop and resistance correlate together. Lithium battery, higher voltage, less resistance, less voltage drop. Lithium battery's faster charging capacity is the next dot point. We'll touch on this a little bit later in regards to a lithium battery and its specs. And then the footprint area of a lithium battery, this has dramatically come a long way in the last sort of 12 to 18 months. The footprint of a lithium battery that you can get now is very compact, and that's just come with technology advances. So a 120 amp hour AGM, an N70 size battery, you can fit easily at least 200 amp hours of lithium, most of the time even up to like 300 amp hours of lithium in that exact same size battery case, in that same footprint. 300 amp hours might be a little bit taller, but they will still be the same width and very close to the same length. And then the last dot point on AGM is a more expensive initial outlay, which we'll touch on in this slide. So dollars per cycle, something that I talk to my customers about a lot, relativity to, okay, yep, I'm going to spend less than half the amount of money on a AGM battery as I will on a lithium. Obviously, these are two lithium batteries that are on the market, and these are their retail prices. You've got your cycles there. Now, dollars per cycle. So you do your calculation. The initial outlay for a lithium battery is going to be more than double, but that battery is also going to last you 10 years, 10 plus years, let's say. 105 amp hour AGM, it's got approximately 500 cycles, and you're paying almost $1 per cycle for that battery. But then you're also going to have to buy another one of those batteries in, let's be a little bit generous and say 3 to 4 years time. So you're going to pay roughly $500 twice. That gets you to $1,000 compared to the lithium, which is $1,300. But you're going to be paying more money per cycles for the amount of time that battery is actually usable, because you're going to only get 1,000 cycles roughly out of $1,000 in AGM, and you're going to get 3,000 cycles, at least 3,000 cycles out of $1,300 of lithium. That's where we get our cents per cycle from. So if you've got the dollars to afford the lithium, I highly recommend you go with the lithium, because it's going to last you, unless you're keeping your vehicle for the next 10 plus years, it's going to well and truly outlast you owning that vehicle. Okay, last point of swapping from AGM to lithium, and that is our chargers. So you've got three ways of charging a battery: DC chargers, solar chargers, AC, mains, shore power chargers, whatever you want to call the last point there. An AGM charging profile, AGM battery will charge to 14.2 volts, lithium battery will charge to 14.4. So they have different charging algorithms. A charger that charges in AGM will charge a lithium battery, yes, but it will probably only charge it to roughly 60-70%. This is all depends on the batteries as well, type of lithium and the type of cells and stuff. So this is just a roughly 60 to 70%. If you have someone that says, or you find advice that says, no, you can't charge a lithium with like an AGM battery charger, you can. It just won't charge it to full. Going back to our capacity and usable energy, yes, you're still going to gain a little bit, but of what you had in AGM, but you're not going to be getting the full amount of gains. And for the cost of things like AC chargers, solar controllers, and DC chargers these days, you might spend another $600-700 to get all three, and they're going to charge lithium to full. So highly recommend doing it properly. One question that we got heaps at the shows was, how do I tell if my charger is lithium compatible? And the easiest way is I'll just go over 2 slides, and it'll have this little LifePo 4 on it there, on the charger, or it'll say lithium. It'll have a lithium charging profile. And Most chargers that have it will have a button that says mode and select through. If it doesn't say lithium or LiFePO4 on there, it doesn't charge lithium. Second topic, are lithium batteries safe? Now, this was a February 2025, I believe, Caravan Park in Victoria. This is on the news, on Facebook. The fiery stated that this fire started from a lithium battery fire. I know straight away, or I can almost guarantee you straight away that this fire didn't start from the lithium batteries that are running the van. If it was started from a lithium battery fire, it was probably a lithium battery that was external to the batteries on the van. And then we'll also touch on this I think it's in the next slide actually. The batteries that we see on the news, it's house fires, caravan fires, car fires, all that jazz. These are a lithium ion battery, which I've got written here. These is a completely different lithium chemistry to lithium iron phosphate. Lithium ion is a lot less stable than lithium iron phosphate, and the more energy you try and pack into the density of that cell of a lithium ion cell, the more unstable it becomes. So a lithium iron phosphate battery, you can pack as much density as you want into a cell and it'll stay just as stable. Lithium iron phosphate batteries, then we also have a BMS, so our battery management system, which we'll touch on later. That is the brains of the system, which also protects it. It's like an internal circuit breaker, internal temperature protection device, essentially. So you've got a more stable cell and you've got a BMS. A lot of the times when we have a lithium ion battery are found in e-bikes, e-scooters, e-skateboards, all those little devices. They're the ones that will ignite and cause us problems. Now, a couple of dot points on this next slide. We've never had to go and troubleshoot and try and find why a fire started, but a lot of times we have vehicles come in and we go, oh, there's an accident waiting to happen here. Dot point number one being incorrect cable sizes for the amperage that runs through that cable. So a lot of the time, this is the inverter cable. So from your DC batteries to your inverter, which is transferring your DC power into AC power, so AC mains power, house power. That's going to be your biggest consumer in your vehicle, in your caravan or RV. That cable needs to be big and it needs to be accounted for voltage drop, because once that cable is running at, let's say boiling a kettle, for instance, you're going to be running 200 amps through that cable. If you run that for an extended period of time, it's going to get hot, and heat creates more resistance. So there needs to be fusing on that cable, which we'll touch on in a second. But yes, incorrect cable sizes, which touches on the next point, not accounting for voltage drop. And again, mainly inverter loads. So like we spoke about before, the higher the voltage, the less voltage drop, the less resistance. So you have to install a cable to the right size, accounting for, okay, how long is this inverter or this device going to run for, how much heat's going to go through that cable, and resistance, to then work out, okay, realistically, the maximum output of this device might be 200 amps, say. We need to account for our heat and our resistance. So if this is running at 200 amps for an hour, this might actually be pulling across the cable closer to 250 amps. So you need to fuse that, which touched on our last point, incorrect circuit fusing. You need to fuse that cable at the correct amperage, but circuit protection is there for the cable, not for the device on the end. So your fuses and your circuit breakers are there to protect the cable. Doesn't matter what's on the end. Fridges and stuff, 12-volt fridges usually have a fuse in the back of them, or their own inbuilt PCB board that is protecting them anyway. So you need to do your cable sizing, calculating your voltage drop, your resistance with your heat over prolonged periods of running the device. Circuit protection is there to only protect the cable. So that needs to be, you want a cable that can handle, say, 300 amps and circuit breaker, fuse it at 250 amps. So that way you know that this fuse is going to blow before the cable reaches its melting point, essentially. Third topic, how to tell you bought a lemon battery. A lithium battery, that is. Number one here, everyone always just goes instantly amp hour rating, amp hour rating, amp hour rating. I've got 120 amp hours of AGM, I need 120 amp hours of lithium or 200 amp hours of lithium. No one ever thinks or talks about BMS and battery management system, okay? That's the brain of our battery. This controls everything to do with the battery. Here on the left, we've got two batteries that are on the market in Australia, both lithium. The left one, the one with the green tick, is the one that we use here in the workshop, and that's not even our battery. That's just the one that we use here at the moment in the workshop. The Lemon BMS is another one that's on the market, and the Lemon BMS one is actually more expensive than the good BMS. So when you hear, oh, you get what you pay for, poor man pays twice, not always the case. bit of an eye-opener, this one. So we'll start off here, 100 amp hour lithium battery. The first thing I'll always look at is our discharge rating. So maximum discharge, 100 amps we've got here. So a good rule of thumb to say that you've got a good BMS is if you've got a 100 amp hour lithium, you should have 100 amps of discharge BMS power. You've got 200 amp hours of lithium, you should have 200 amps of BMS discharging. Once some brands BMSs max out at 250 amps, so once you start to get up to like those 300 amp hour batteries, it might just max out at 250 amps, but the amp hour rating might still go up, so it won't be sort of on par. Good rule of thumb is if the amp hour rating and the discharge BMS is on par with each other, you know you're going to get a good BMS, and then the charge rate should be at least half. So if you got a 100 amp hour lithium, 100 amp discharge, should be 50 amp charge. 200 amp hour lithium, 200 amp discharge, should be 100 amps a charge. Another good rule of thumb. It can be more than half, but most of the time, it's just half. Now, one thing that I've never come across personally, but I've seen a lot of things online with actually testing the batteries and putting them through their paces, is a battery might say it's got a maximum discharge rating at 100 amps, but when you test it, it'll actually discharge at 200 amps for like a minute. Realistically, that's a fail in my books, because how do you trust what the specs of that battery is actually telling you is correct? That's one other little thing to, when you're buying, got to do a bit of research or ask questions. Next point is our series parallel connection. This one here has got written 4, so this is having 4 100 amp hours to make a 400 amp hour 12 volt bank, or having 4 batteries to make a 48 volt 100 amp hour bank. Same. On the lemon side, they might state 0, or they just won't have anything written at all, because these batteries are not capable of being linked up together. Now, on a lot of high-end lithium batteries, they'll have like an Ethernet cable, like a RJ45 Ethernet port that you can plug in and have a master battery and then slaves. There's also a lot of batteries that don't have that are still capable of being wired together, and they will work to balance out with each other. A good example of this is in our previous videos when we've been doing Caravan upgrades. We charge the batteries and we balance them, and then I'll go on the Bluetooth app on my phone and show you that all 4 cells are exactly the same voltage, because the BMSs have worked together to balance all 4 cells in each battery, so that your 8 cells across your battery bank are all the exact same voltage, and your batteries are running at the same nominal voltage. That's good. Charging temperature range and discharge temperature range. So a good BMS is a very smart device. Now, if we are charging, let's say we're charging from our multi-plus and we're charging at 120 amps, and we reach that 45 degree cutoff, the inverter is smart enough to cut off the charge side, so it won't allow any more charging because you've reached your high temperature incoming charge preset, which is 45 degrees, but it is smart enough to still allow you to draw power out from your discharge side. Obviously, if you hit your discharge temperature, it'll just turn the battery off. The battery will still sit there, it's fine. That's what the temperature presets are there for. It's still safe, it's not gonna go bang. And then our reset is this, so like if you hit 55 when you're discharging, 50 degrees is usually the reset. So 5 degree is usually the reset of when the battery BMS will go, all right, sweet, we can turn on our charge and discharge side now. We're good to go. That also touches on the actual quality of the BMS. So most batteries that will read charging and discharging, our batteries and the batteries that we use at the moment, they have 5 temperature sensors. You'll have a temperature sensor for each cell, and you have an internal BMS temperature sensor as well. Sometimes one temperature sensor might be on like the active or neutral of the battery terminal as well on the inside. But yeah, they got 5 temperature sensors. A lot of the time with the Lemon BMS, with a BMS that's just got operating temperature range, it's just got one like MOSFET temperature sensor, or just one internal battery temperature sensor. That one temperature sensor just reads the whole battery. You hit the 55 degree, it'll just turn off. Hit 50 degrees, it'll turn back on. Again though, testing those temperatures is another thing, because I've seen a lot of them that actually don't do what they say they do. Now, probably the most important topic, electrical installation laws in RVs and caravans. Like I said earlier, I'm an electrician by trade. I'm a licensed electrical contractor. This book here is our electrician's Bible, the AS 3001. This book is a legislative law, okay? If a lot of the times, and every time we've done these seminars, people go, oh, I've never heard of the AS 3001, unless they've done a bit of research. And a lot of the time it is because you don't hear about this law book until something goes wrong, and the insurance company throws the book at you. That is why we were asked to do these seminars at the shows, basically. And because at the shows, a lot of people are there to buy vans, or look at vans that they're going to potentially buy. So questions to ask Again, when we do all our caravans and vans and RVs and sprinters and all that jazz here, we will give the customer a certificate of conformance, an electrical certificate to say, yes, this vehicle, this electrical installation has been done by someone who is a licensed electrician. So they are licensed to do all the 240 AC wiring side of things, as well as the battery install, the solar connections, and stating that this whole electrical system complies with the AS 3001. And then we give that to them. They can give that to the engineer if they need to get the vehicle engineered, and to the insurer, because I've had a lot of customers that have been like, oh, I want to upgrade to lithium, but I just spoke to my insurer and they won't insure us if we do the lithium upgrade. And I said, if you come to us and do the upgrade, they will insure you because we'll give you a certificate. And it basically just means that all the onus of the electrical system gets taken off the insurer and it's put back onto me because it's my license number at the end of the day. So again, like I said, we're going to touch on what I see as the main topics, and the electrical installation laws are quite vague. So you have to do your best to make up your best interpretation as a professional and in the safest way of the laws. So who needs to comply with these standards and when you need to comply? So if your vehicle or system was manufactured after the 20th of November 2023, you need to comply with these standards. If your electrical system has been modified, that is not a like-for-like replacement, after the 20th of November 2023, you also need to comply. So let's say it's 2024, last year sometime, and we have an AGM battery in our Caravan, and we will swap that out and put a lithium in. That is not a like-for-like replacement. So you need to bring the whole electrical system up to scratch with the new electrical laws to be compliant. I would say, obviously, swapping AGM for AGM, that's like for like, therefore you can just do that and you're okay. My interpretation of the wiring rules is if there's no DC charge in the electrical system and you go and install a DC charger into it, that is not like for like, therefore you have to bring the whole electrical system up to scratch with the new laws. The last dot point there is if your vehicle or electrical system has the ability to be plugged into AC mains, shore power. Basically, the AC plug, the plastic Clipsal AC plug, or the stainless Victron one that we use on like a lot of the Sprinter vans, you can be plugged into an external supply is what the rules state. So that's our 240 AC. Give you two scenarios here. You've got a slide-on camper that's got a pop-top bed section, so the whole camper is all one section. It's just 12 volt. It's got lithiums in there, but you don't have the ability. There's nowhere to plug in an AC charger, or there's nowhere to plug in AC mains exterior plug-in to power some power points in the van. Technically, you don't need to comply with all the lithium battery boxes and laws because your system can't be plugged into AC mains or shore power. Obviously, it is best practice to do the installation as per these laws. That way, if you add it later in the track, you know that the rest of the system is up to scratch with the laws. You don't have to change anything. The second scenario being we have, again, a slide-on camper, but it does have a plug-in on the side. You have to bring that whole electrical system has to be up to scratch with the laws. Minimum requirements for lithium batteries. Now, this is the batteries themselves. Again, this is basically the BMS. So the battery or battery bank must be monitored by a battery monitor designed for lithium batteries, displaying state of charge as a percentage and voltage. Now, this battery monitor can be wired or wireless. The next dot point, this monitor must be continuous, must be 24/7. So if we have a battery here and we have our fuse panel here and our battery monitor is wired off our fuse panel, but we have a main switch in between the battery and the fuse panel, and we can isolate that main switch and it kills power to our battery monitor, that is not compliant, okay? It must be 24/7. As you see in the first dot point, it says wired or wireless. So a lot of batteries, going back to the batteries with good BMS, a lot of the good BMSs on the market in Australia will be Bluetooth. So you can get them on your phone, Apple or Android. That complies because it is Bluetooth direct to the battery. It is 24/7. Some of them, even when the battery is actually turned off, you can still get onto the Bluetooth app. The BMS must protect against over and under voltage, over and under temperature, and over current. Now, this is going back to our over and under voltage is regarding lithium batteries will have a cutoff voltage of 10 volts, and then they'll have a high cutoff voltage, depends on the brands and depends on the cells, so you can't overcharge it. I know like our ones all work because I'll say set my power supply, lithium battery charger, to say 14.5 volts, and as soon as the battery is full and it's at 14.4, it'll just cut off and it'll come up on the BMS app and say, oh, this battery is full. So the BMS is doing exactly what it's meant to do. Over and under temperature, again, goes back to temperature sensors with your charging and discharging temperature ranges. And then over current is our maximum discharge current. You obviously have the charge current, but your discharge current will be more in 90% of cases. So actually discharging that, let's say 200 amps off a 200 amp hour battery, discharging that 200 amps, but as soon as you go over to like 250 amps for, I don't know, 10 seconds, bang, it cuts off. Okay, that's means it's working and it's compliant. Now, last point is the battery must be IEC 62619 certified. This is an international safety standard. This is per battery. So I've seen a couple or one brand or two brands, I think, give a certificate for like their range of batteries. No, not okay. The certificate must be for each model, so each like amp hour. So let's say we've got a brand that's got 6 batteries. The certificate must be for each model of batteries, and the certifying is the actual battery and its case and how it's made. That's the certification, and it's up to each brand of battery manufacturer to do their own certification for each model battery. A lot of the cells we see in Australia already have that certification, but we are talking about the actual battery, not the cells here. The actual battery must be certified to this standard to comply with your electrical safety laws. Okay, next slide. Minimum requirements for installations now. So we're moving away from the actual batteries themselves. This is for installations. So the battery or battery bank must be installed externally to the habitable space, meaning the battery compartment must be fully sealed, so airtight, gas tight, from the structure where the sleeping quarters reside. So the exact wording in the installation law book is prevent egress of gas into the habitable space. So your habitable space is your sleeping quarters and anywhere that you can access from somewhere that you can sleep in that same compartment. So anywhere where you're asleep and you can sleep, and anywhere that air, oxygen, whatever you want to call it, that space there, anywhere that you can access that is in the same airspace as that sleeping quarters, that is all habitable space. So if you're sleeping on your bed and you walk to the other end of the caravan and you open up, you've got your shower door there, you open up your shower door, or you open up your bathroom door and you got like a cabinetry, you open up the cabinetry, anything that you can access in that cabinetry, for example, that's all considered habitable space. So it has to be fully airtight, gas sealed from the habitable space, and then it must be vented as well, which we'll touch on in a sec. So a small dot point, the battery must be secured to prevent movement no more than 25 millimeters in any direction when a pulling force of twice the battery weight is applied through the center of gravity. There shall not be more than 4 conductors connected to a single battery terminal, so you can't have one battery terminal having 5 or more ring terminals, connectors, whatever you want to call them. Circuit protection devices must be installed either within 200 mil of the battery terminals or directly outside the battery compartment. That's the last point, which I was getting to. Battery boxes must be fully airtight with ventilation to the atmosphere. So you've seen a lot of our past videos with our electrical installation laws. Probably the Malibu video is a good example because they had a Perspex lid. Battery box, batteries inside, Perspex lid, venting out the side through the floor of the vehicle so that any of the air inside that battery box doesn't leak into the space of the van and it all goes out the vent. And then there's one more. Batteries must have reasonable access to be removed by a professional. So that is saying I can't install the battery box in the bottom of a kitchenette cabinet and the whole kitchenette's got to come out to be accessed. To access the battery, it has to be reasonable access. That's the end of the seminar part of it. What I'm going to go through is go back through a couple of dot points and we'll talk about some more things in a little bit more depth. So just going back to the slide before. In regards to the boxes, there's a label kit which must be on the boxes. You would have seen the labeling kit on all our past videos. It basically just states that this box is fully sealed from the habitable area. It contains X type of battery, so lithium, and it contains how many amp hours of energy. Now, a lot of people say to me at the seminars, oh, like the boxes, is that to deprive the battery fire of oxygen? Now, if you have a lithium battery that's going to catch fire, the energy inside the lithium cell is going to combust either way, and it doesn't need oxygen to do that. So Yes, the battery box will deprive it of some oxygen, yes, but it's still going to sit there and smolder away anyway until that energy in the lithium cell is all burnt and used up, is the simple way of putting it. Going back to our Caravan fire, like I said to you, I said I can almost guarantee you that the lithium iron phosphate batteries that were running this fan weren't the cause of the fire. Now, going back to this point here, I have the suspicion, I don't know because we never found out about that fire, but it could have been literally something as simple as a loose active terminal on the battery, or neutral terminal for that instance. It was a little bit loose and they were running the aircon all night, okay? And that terminal's just getting hotter to the point where it melts, so much heating up the lithium cells, and they've caught fire. So again, it's not the actual battery that's causing the problem and catching fire, it's the installation. Again, this is why you use the correct spec nuts, spring washers, not stainless steel, brass fittings, all that sort of stuff, because you can run into problems essentially. And it's always a good rule of thumb to go, all right, yep, we've just done a lap, or we're halfway through our lap. Let's book it in, our vehicle in, do a little bit of maintenance check on it, get an auto electrician to go through, tighten up all our battery terminals, any screwed down style, like Phillips head style, bus bars, our fuse panel connection, any of that sort of stuff. Obviously, yes, our fuses and circuit breakers and all that stuff are there to protect the cable, but they've also got to be done correctly and the cable size being correct to actually protect anything. A third point that I want to talk about here. Now, I believe there is a massive reason as to why you should buy a lithium battery with a Bluetooth BMS, and that is because, let's say we're in our Caravan, it is a massive help with troubleshooting a problem. If you are able to get into the battery, Bluetooth from, and see the BMS linked directly to it, massive help with troubleshooting. We wake up in the morning, or we come into our van once it's been in storage, we go to turn our lights on and go, oh, the lights aren't turning on. What's wrong? Let's say there's nothing in the van on. We can go, all right, straight away, let's go to the batteries, turn them on, open up their Bluetooth on our phone, let's check the app. Okay, are the batteries at 0% and they've drained and they're flat? Or if we see, okay, we go onto the app and we go, all right, our batteries are at 50% charge. Why are we still not getting power? Straight away, you can know, all right, there's a fuse somewhere that's broken. There's a circuit breaker somewhere that's been tripped. There's an isolation switch that we need to turn on because we've had it in storage. If you don't have a battery that has got the Bluetooth directly to the BMS, it is a nightmare to try and troubleshoot. Yes, you can do it, but the ones with the Bluetooth save you so much time. Again, it helps troubleshoot in the way you go, all right, say, oh, our lights are working, but our inverter's not working. Check the battery. Yep, it's obviously got charge because our lights are working and our lights aren't running off the solar that's coming in. You should, if your vehicle's electrical installation is up to scratch with the new laws, have a way to isolate your solar through a circuit breaker style main switch or some sort of isolation switch, or a fuse or a manual reset circuit breaker. You can turn that off. Yep, our downlights are still working, but our inverter's not working. Straight away, you can go, all right, we need to find the circuit breaker or fuse that's going from the DC batteries to the inverter or a main switch. That's probably going to be our problem. Sure enough, that's what your problem is. Helps massively with troubleshooting. And there's a massive brand in Australia that doesn't, I don't know why, they just refuse to run inbuilt Bluetooth on their batteries, and we don't use their batteries because of that. So it's as simple as that. I might leave it there for this video because it's already 40 odd minutes long. We got the QR codes there on the screen. That'll take you to our link trees. If you need or you want any advice tailored to your system, we can also do that. Reach out to me via email is the best way to do it. If you need our services, we're here in North Wollongong. We are also going to trade shows for the rest of this year, where some of them we will be doing this seminar again as well. I hope you enjoyed the video. If you've got any other questions, let us know. I'll do our best to answer them. If we get a few questions, we'll make a separate video and answer them in that. Thank you. Have a good day.